Okay, so our Google Meet is up and running. Our video is up and running. So let me talk a minute about the test, and then we'll actually get into the material of the test. So the test is 21 questions. You do have a long free response question, and then you have several short answer questions. About half of the test is naming compounds and writing formulas. Okay. I have all of your old quiz. So I have quiz number 2 all the way through quiz number 5. If you took those, they are open to you to view and see your correct answers. Now, if you didn't take it, there's not a whole lot I can do. Okay. But I think all of y'all have taken at least one of those quizzes, and they're all pretty much the same thing. So you don't necessarily have to go through each individual quiz to get the most benefit from it. So they are all opened from quiz 2 to quiz 5. They are all opened up. You can go in, you can look at your answers, you can look at the correct answer to help you study those. And then for the test we took on Friday, or the quiz we took on Friday, so the Tuesday before that, I posted a study guide with Quizlet links for rules for naming acids, rules for naming ionic compounds, covalent compounds, polyatomic ions, and then there's tons and tons and tons of practice questions. So I would go through those as well and spend some time going through those, make sure you know how to do those, okay? So what I'm going to do is I'm going to let y'all go ahead and open up. Here's what I need you to open up. You open up your quizzes. Open up this hydrate thing. I'm going to take that off of today, so we're not going to do that. But open up your, I think this was on day 19 maybe, the molecular mass and mole concept and mole calculations. Open up that worksheet and your percent composition worksheet, because you will have lots of those problems on there. We'll talk a minute about mole ratio, but there won't necessarily be any questions like that, like this worksheet on your test. So do that while I get rolled, and we'll go from there. And y'all will probably have to tell me as the who is taking the line.
Yes, ma'am.
Caitlin?
Right?
Caitlin?
I think she's saying.
Hayden? Thomas? Riley? Here. Ty is here. Jackson is here. Isaac is here. Martin is here. Hayden is here.
Where did you say we find where she does?
I think it's either the 19th or maybe the.
Day 12.
Thank you.
What's the name?
Practice world.
Oh my gosh. What?
Okay, so. All right, so I'm going to start with the problems first, and then we'll go over the naming part second. So, on molecular weights are super easy. You just got to remember one thing, and you will have a periodic table. You will have them. Actually, I may go back and put it in each question. So you will have a periodic table right there in the question itself. That will have atomic masses on it. It will have the names of the elements on it, all that good stuff. So you can use that to work with. But all you have to do from atomic weight is just add up the atomic mass of every element in the formula. That's it. The subscripts tell you how many there are, so you may have to multiply. You may have to multiply, then add. That's it. It's so simple. So in H3PO4, I have 3 hydrogens. So what I'm going to do is I'm going to take 3 and I'm going to multiply it by the atomic mass of hydrogen, which I'm going to look up on the periodic table, and it is the decimal number on the periodic table. The decimal number, okay? Not the whole number, the decimal number. So for hydrogen, it's 1.008.
We do like, we just do 3, like decimal.
Yes. If you want to be super precise, you could just write down whatever decimal is on that periodic table because you know that will be right. Okay? And then phosphorus is 39.97 something. Is that right? It's really hard to see. What am I doing? How stupid am I?
30.
It's right here. You're right. It's 30.97. 30.97. I only have one of those. And then I have 4 oxygens. And we always round oxygen to 16 because 15.999. So, and then I'm just going to multiply that and add them all up. And that's my answer. That's it. And it's grams per mole. Remember, you have to put your units. So it's grams per mole. Okay? Because in 1 mole of that, I have that many grams. Okay? I would go back through the 2 POGLs. We did a POGL on molecular weight and mole concept. We did a POGL on empirical formulas. You need to go back through those POGLs. Okay? And maybe just redo them. Okay? Or at least look at them because they had lots of good problems and questions on there. And I may go back through those with us. So somebody add that up for me real quick and tell me what it is. I can give you a rough estimate. It's going to be 64 plus 31 is 95, and then 95 plus 3. So it's going to be around 98 something or another.
95 plus 37.
64 plus 31.
97.99.
Yeah, that sounds about right. Okay. So 97 point, let's just say 98 grams per mole. Okay. The only ones that may look a little funny to you, and then we're going to move along, is the ones with water in it. It may look funny, but you do exactly the same thing.
You do the same thing on the words too.
Yes, you do the same thing on the words. Now, you take the words and you make them a formula, and then you find your molecular mass, which is why we spent all this time naming compounds and writing formulas. Okay? So with this, I'm going to do the same thing. I'm going to take my mass of copper, which is 64. I'm just going to round these to whole numbers for convenience sake. On a test, you wouldn't do that. Sulfur is 32, 4 times 16 for the oxygen. And then I've got to figure in these 5 waters. So that's going to be 10 hydrogens, because 5 times 2 is 10, right? And then it's going to be 5 more oxygens, because that 5 goes with the oxygen as well. Okay? These numbers in front are called coefficients, and they work just like coefficients in math. Exactly like coefficients in math. You multiply them by everything they come behind or come in front of. Okay? And then I just add all that up together. That's it. Okay. Does that make sense? Is that good? If it's not good, please if you don't want to ask a question, that's fine. At least give me a frowny face or a shake of the head or something so that I know I need to go back and do this again. Because if y'all all look at me like, hey, I know what I'm doing, and I'm going to think, you know what you're doing. And if you do, great. But if you don't, that's going to be bad. And it's especially hard to tell because I only see half of your face. So you're going to have to really be expressive. Okay? All right. So, questions on molecular weight? No? Okay, here we go. All right, mole concept down here. So on this one, we are converting moles to grams. And that's just because that's what it asked me to do at the very beginning in the directions. It said to express each of the following in grams. So to do that, especially on the ones with words, let's do one of those with words. Okay? So 0.25 moles of potassium, let's do this one. 0.10 moles of iron 3 carbonate. Well, I have to know my polyatomic ions. Carbonate is CO3 with a -1 charge. Iron is a what charge? Iron's Fe, but what's the charge on it? What does that Roman numeral tell me? It's a transition metal, but what is the amount of the Roman numeral tell me? The charge. It tells me a charge. So this is a +3 charge. So if iron is a +3 and carbonate is a -1, how am I going to get those to balance out? Because they're ionic compounds, they have to balance. Drop and swap. I only use drop and swap with metals. Okay, I've discovered that second period. Covalent compounds, you don't drop and swap. Just metals. Just metal and iron. So if I drop and swap, that means I'm going to have 1 iron and 3 carbonates. That's my formula. Okay? I put the parentheses around the carbonate to show I have 3 of those whole things. So I take 0.1 moles and I want to turn it into grams. So if I want to turn moles into grams, where does moles have to go? On the bottom. Moles of iron. Oops. Carbonate. Okay. So in 1 mole of iron carbonate, how many grams do I have? How am I going to figure that out? This is why we learn molecular mass, molecular weight first. So if I want to know how many grams are in 1 mole, what am I going to do with that iron carbonate? I'm going to find the mass. How do I find the mass? Not yet. How am I going to find the mass of iron carbonate? Yeah, what we did before. I'm just going to find the mass of iron, 3 carbons, and 9 oxygens, and add them all together. How did I get 9 oxygens? Because it's 3 times 3 right here. Okay, good. All right, so the mass of iron is 55.9. And then carbon is 12, but I have 3 of them, so that's 36. Okay, I need a calculator, guys, because all this ain't going in my head. So 55.8 plus 36 is what? All right, 91.8. And then I have 9 times 16. That's 9 times 16. 144 plus, now add it to the 91.8. 144 plus 91.8.
235.
235.8. So that's what's going to go right here. Okay? Cancel out there. My moles cancel. So I take 0.1 times 235.8. That I can actually do without a calculator. I'm just going to move the decimal, right? But just in case, multiply it out. 0.1 times 235.8. Remember, I multiply across the top. I divide by what's on the bottom. So 0.1 times 235.8.
23.58.
There we go. 23.58. And if I divide by 1, that's the same thing. Grams of iron carbonate. Okay? Yes, no, maybe. Slight furrows.
So you multiply the top, once you get your answer, then you divide by.
By what's on the bottom, yes. Yep. Okay, let's try another one. 0.3 moles of phosphorus pentachloride. Well, what's the formula for phosphorus pentachloride? Is there metal in this? Is phosphorus a metal? No. Is chloride a metal? No. So it's a covalent compound, which makes it super easy. All I do is take the prefix, and that's how many things there are. So there's 1 phosphorus. How many chlorines? 5. PCl5. So somebody give me 5 times 35 for the chlorines plus 31 for the phosphorus. 5 times 35 plus 31.
175.
175. Oh, 175 is 5 times 31. Net 35. Now add 31 to it.
206.
206 grams per mole. Okay, I want to change 0.3 moles to grams. So, what goes on the bottom?
Moles.
Okay. What goes on top?
Is it phosphorus? Grams.
Grams of phosphorus chloride. Phosphorus pentachloride. I'm just changing grams to moles. And in 1 mole of phosphorus pentachloride, I have that many grams. So what is 0.3 times 206? And that's my answer. That's all I have to do.
61.8.
Now, these worksheets, both of them are really good to do because if you haven't noticed, all the answers are in the back, and I didn't give you nearly all the problems. So you could very easily go back and pick some of the ones that you didn't do, work them out, see if you got it right. If you got it right, then hey, you know what you're doing. If you didn't, work backwards till you figure out what you did wrong. Okay? So that's one way that you can study for this kind of test. Okay? So any questions?
Will we get questions at this time?
Mm-hmm. Yes, definitely.
How many is multiple choice?
15 or 16,
There's 21.
maybe 17. Yeah. there's 21.
And then let's go on.
And you will have some short answer questions that are like this where you're going to have to write it out and give me the answer. Show me your work because I will give you partial credit, especially on those, well, on the short answer ones. If you show me all this work and you rounded your mass number a little more than I did and you got a little bit different answer than me, I'm not going to count it wrong unless you don't show me your work. If you don't show me your work, then I don't know that you know what you're doing. But if you show me all this, I know you know exactly what you're doing, and I'm not going to count off one thing wrong. Okay? Because this isn't a can I do my arithmetic test. This is do I understand mole test. Okay? So show the work. If your arithmetic's a little off, I don't care. I'm not worried about it. But if you don't, then we have a problem. Okay? So you will have some where you have to work these out and show me your work. Then some of them will be worked into multiple choice as well. If it's worked into a multiple choice, pick the closest answer to what you get.
So,
Because I'm not so mean, and even they are not so mean, where they're going to give you difference of a decimal point that you've got to figure out. They're not going to do that. It's going to be obvious. Okay, so, okay, questions on this? All right. Okay, then, all right, so we're going to go here. Let's try one of these. Let's try number 10. 8.8 grams of potassium carbonate, and we have to change it to moles. So now we're doing the reverse. It's going in the other direction. So what is the formula for potassium carbonate before we start? Because that's where we have to go. Potassium carbonate. KC, yes. Like it so far. C what? O what? Yeah. It's not one. It's 3, yes. Carbonate is CO3. It has a -1 charge. So the potassium has a +1 charge. Because how do I know potassium is +1? We just go way, way back. How do I know potassium is +1? Did I just guess that? Am I super smart and memorize the charge on every single element on the periodic table? No. What, Ryan?
It's because it's in the first.
Yes, it's because it's in the first column of the periodic table. There we go. So we know that's +1. We know carbonate. Now I do have to memorize those. Okay. Carbonate is -1, so they balance out like that. So now we have to figure out the molecular mass of carbonate. So that's going to be 39.1 plus 12. Somebody add these up for me. 39.1 plus 12 plus 3 times 16 is 48. So 39.1 plus 12 plus 48. What does that give me? 99.1 grams per mole. All right, so I have 8.8 grams potassium carbonate. Grams potassium carbonate. Moles potassium carbonate. All right, in 1 mole, how many grams did I figure out I have? I just figured it out. 99.1. Okay, so now I'm going to do the same thing I was doing before. I'm going to multiply across the top. 8.8 times 1 is just 8.8. And then I'm going to divide by 99.1. So what does that come out to be? That one's too hard to do in my head. I don't want to do that one.
11.261.
11.261 moles. No, that's not right. That can't be right. How do I know that can't be right? Because I got 8.8 and I'm dividing it by 99. So am I going to get an answer like 11?
That's really.
You should get a small decimal number, right? When you divide a big number into a little number, won't I get a small number for my answer? Yeah? So it should be decimal. So let's try that again. What did you get?
0.0887.
Okay, let's give me 2 digits after the zeros. 0.88.
0.88.
There we go. Moles. Now that kind of makes sense because I take 8.8 and I'm dividing it by almost by 100, so I'd just be moving my decimal. Anytime you divide by 100, you move your decimal 2 places. So that makes a little more sense.
I put the numbers in the wrong spot.
Yes. If you put them in backwards, and that's what most people wind up doing. So that's where this thing up here is smarter than this.
Oh, no.
Yes, because this is a machine. All it does is what you tell it to do. That's it. And calculator, it just tells it what you tell it to do. It's got no reasonable, rational thinking. So when you get an answer like that, your brain should be smart enough. If you look at it, it's smart enough to realize that's not right. Okay? Just because the calculator said it's right doesn't mean it's actually right. So when you're dividing a small number by a big number, you should always get a decimal. If you come out with a whole number, you did something backwards. Okay? So you need to be able to mentally think that through. Okay? All right. So like I said, there's tons of these. They're all kind of basically the same thing, and there's all the answers in the back. All right. Let's look at percent composition. Percent composition is pretty easy too. With percent composition, what we're doing, what is it in math? What does a percent mean? Something out of the whole. Exactly. Something out of the whole. In chemistry, it's exactly the same definition. We are going to find the part out of the whole compound. So we're going to find the mass of the entire compound. We're going to divide that into the mass of one particular part of that compound, and that will give us the percent. All of these should be decimals, and then you multiply by 100 to make it a percent. Okay? To make it a, yeah, percent. Okay, so let's do the aluminum oxide. So we want to find the percent composition of aluminum and oxygen in aluminum oxide. Well, I got to find the formula first. So what's the formula of aluminum oxide? So look on your periodic table and find aluminum. What's the symbol? Al. What's the charge? What group is it in? +3. Is aluminum a metal? Yes. Well, just think about an aluminum can. You know what that is. That's a metal, right? All right. So it's a metal. What is the formula for, or the symbol for oxygen or oxide? Oh, what's the charge of oxygen? -2, because it's in the 6th column. All right, so here, since we have a metal and we have a nonmetal, that's an ionic compound. I want to make sure you write that down. Ionic compounds are metals and nonmetals. If you know what kind of compound it is, you can go and memorize and know what rules to follow. Ionic compounds means their charges have to balance, so we got to do the drop and swap. Okay, so I'm going to need 2 aluminums, and I'm going to need 3 oxygens. Okay? Now I have to add it all up. So I got 2 aluminums, so that's 2 times 27, which is 54. And 3 times 16, which is 48. What's 54 and 48? My brain's already, it's done. 54 and 48. That sounds right. 102. 102 grams. Okay, so that's my total. My total mass is 102. To find the percent aluminum, I am just going to take the 2 times 27, which is 54, and I'm going to divide it by 102, and I'm going to multiply by 100. That's it. So what does that come out to be? 54 divided by 102 times 100. $52.94. Okay, now to do that's percent aluminum. To do percent oxygen, I'm going to do the same thing. I'm going to take the oxygen mass, 48 divided by 102. Somebody will do that for me. It's going to be around 50%, but a little bit less than 50%. So what does that come out to be? I know what we're having for lunch today.
47.0.
Stop telling you. Okay. Well, I'll just wait for one of y'all to come back. All right, so we got 47% oxygen and 52.9% aluminum. That's it. That's all you have to do.
How many of those?
I don't know. There's okay, so there's like 10 naming and formulas, and there's like 15, or let's say, yeah, pretty much the rest of it, the rest of the test, even the free response stuff, is going to be a mix of changing grams to moles and moles to atoms or molecules and percent compositions. Should be. Yeah, in theory, yes.
Theory's not always
Study. No, don't just go by theory. Let's study. All right, so this mole ratio thing, I'm going to go over this really, really, really quick. None of these actual questions will be on the test, but there will be one similar to it. So I think I'm gonna add a page right here. And I'm gonna add this question or a couple of questions. So if I have 1 mole, let's do it a little. Let's. So if I have 0.6660 moles of NH3, here's my question. How many moles of hydrogen is that? And how many atoms of hydrogen is that? Okay? So what you're going to do is you're just going to use the formula. We're not going to use the equation. So we're going to use the formula, and I'm going to always, in all these problems, you start with what you're given. So just like in math. So in math, in this problem, what am I given? What am I? I'm given NH3 and what else? What else am I given? Moles of NH3. How many moles? 0.6. Okay, so I start right there. 0.600 moles of NH3. All right, I don't want moles of NH3 anymore.
So they get rid of some moles.
So moles of NH3 goes on the bottom. Be specific.
I knew that.
Okay, I know.
I really did.
All right. So I want to get rid of moles of NH3. What do I want to get in this first question? Moles of hydrogen. All right. So if I look at that formula, what's the ratio of NH3 to hydrogen? How many hydrogens are in that formula? 3.
3 of them.
Exactly. So for every 1 mole of ammonia, how many moles of hydrogen do I have? 3. Exactly.
Is that easy?
Yes, it's that easy.
See, it's so easy when I watch you do it stuff. When I do it on my own.
I know, which is why I give you homework to do so you can practice it. So you can practice it. Okay, now let's do one more. We're not quite done with this. So let's say I now know how many moles of hydrogen I have. But I don't want that anymore. Now I want to know how many atoms of hydrogen that is. So
moles hydrogen goes on the bottom.
yes, moles of hydrogen goes on the bottom. And what am I trying to get? Atoms of hydrogen. Okay, now this you just have to memorize. If you don't memorize this, you are going to be lost. How many atoms are in a mole? Somebody's saying it. I hear parts and pieces of it.
6.022 times 10.
Oh yeah, I did.
Yes.
I did that.
In 1 mole of anything, there is 6.022 times 10 to the 23rd of those things, whatever those things happen to be. Right now, we're talking about atoms. Could be talking about donuts if I wanted to. It'd still be the same number. Yeah, I know. Okay, so 0.600 times 3 times 6.022 times 10 to the 23rd. So the next thing we have to make sure is, do we know how to use our calculator? Because I hope we're not doing this in your head. I mean, I guess you could, but I'd really rather not do this in my head. But if you don't know how to use your calculator correctly, you'll get it wrong every single time. So you're going to need a scientific calculator.
But we're gonna use our own calculator.
Please, I would definitely use my own calculator. Because you've become used to it, you know what buttons are what, and yes, use your own calculator. I just pulled up this one because it's right here. So I'm going to take 0.6. So everybody needs to have your calculator out if you have one. Have your own calculator out that you're going to use. If it's on the computer or on your actually handheld, fine. 0.600 times 3. That's what's there. Times, now I'm going to multiply it by Avogadro's number. And the way I do that is I put in 6.022. And here's the part that everybody messes up. you hit this key that says EXP or capital E, capital E. Those are the most common ones. Now, there's all kind of calculators out here, and then some of them do some really weird stuff that I have no clue about because I don't have time to learn every calculator ever made. You bought it. You have to learn how to use it, okay? So most of them, it says EXP or capital E, and you'll get that weird little symbol there, and then you put in the exponent, 223. Do not hit times 10. That's what that EXP key does. It internally does the times 10.
Press like equal sign.
And then when you're done and you've got that number in, then press the equal sign. And there's your answer. Hopefully your calculator is going to give it to you already in scientific notation instead of like this one.
Yeah,
It gives me all that mess that I have to then count out. But
You have to count all the way to 12.
so we got 3, 6, 9, 12, 15, 18, 21, 22, 23, 24. 1.08 times 10 to the 24 is what you should have gotten. So 1.08
Times 10 to the 24.
times 10 to the 24
Yeah.
atoms of hydrogen, okay? So make sure you get that. Make sure you get that number because you've got to know how to use your particular calculator. I can't help you on a test because I probably don't know how to do your calculator. If it's not a Texas Instrument, an old Texas Instrument, simple one, and I don't know. So did everybody get that answer?
Yes.
The most common mistake is I see people literally put in the times 10, and that will make you off every single time. Okay. All right, so you will have some of this type of problem. I won't make you necessarily look at an equation to get the mole ratio, but you do have to understand that even within the formula, the subscript tells you how many moles of that thing you have. So in NH3, I have 1 mole of nitrogen and I have 3 moles of hydrogen because of those subscripts. And if there's not a subscript written or a coefficient written, it's an understood 1, just like in math. Chemistry has a lot of math to it.
Yeah. More than math.
It can't have more than math.
I swear.
Maybe, I think.
You may have the same amount, but it can't have more than math.
Math is little.
I know.
You know what my grade is in math?
No.
It's 100. I have a 77. I'm telling you, it's more difficult.
Thanks for announcing that.
It's the application of it. That's what's, because everybody in math hates word problems, but you don't do word problems all the time in math, right? In here, that's all we have. It's just one great big math word problem.
If you look at the math that we had over the weekend, that it had like 4 word problems.
Yeah, but this is every single question is a word problem.
Yeah, word problems sucks.
I know, but you know what? Word problems are what are actually real life. You get a job, nobody's going to hand you a little formula sheet and say, here, work out X plus Y. They're not going to do
Are
that.
they going to give me a work problem?
Yes.
Should not.
They're going to say, I need you to find this. And you use all that math stuff that you've been learning to work it out.
I'm
Exactly.
100
So-
on my last math test.
Jimmy
I'm
got
about a 50 on this. Yeah.
All right. Let's move along. Okay, so real quick over this, real quick. Look right here. Real quick. Okay, so here's our balanced equation. Balanced meaning we have the same number of atoms on both sides. We'll talk about that more later. But we want to find the mole ratio. So just like in math, a ratio is just a comparison of two things.
The homework is due.
This is part of the homework. This is so we want to know a ratio of two things. So if you use that's not the one I wanted. Let's go up to this one. There we go. So what is the mole ratio of water to hydrogen? So I look at this equation. What coefficient is in front of the H2? What number? Coefficient, just like in math. What number is in front of the H2? A 2. Right here. See? Right there. What number is in front of the water?
1.
2.
2.
Oh, I was looking at the
Okay.
For some reason, that's
Let's go
space.
back. Let's go back to math. In math, if I have 2x, the coefficient is the 2, correct? Right? Same thing. The number in front of the water, that's the coefficient. So the ratio of H2 to H2O is 2 to 2, but just like in math, we don't leave it that way. What do we do with it?
Simple.
Simplify it to
1 to 1.
1 to 1.
How's it 10 to 2?
Because this coefficient is 2 and this coefficient is 2.
So
Coefficients are the numbers in front, just like in math. And just like in math, they go with everything they're in front of. Okay? Same concept. So if I had 20 moles of H2 and plenty of oxygen, how many moles of water could I make? So you can reason this one out because it's a 1-to-1 ratio. But I want to show you how to do your railroad tracks to figure that out. So we're given this first. So that's what we write down. You write down what you're given first. 20 moles of H2. What am I asked to find?
How many moles?
Moles of water. So I need to get rid of moles of H2 and I need to get moles of water. So what am I going to do?
Mole H2 on the bottom.
Moles of H2 on the bottom. What's going on the top?
Moles of H2O.
Moles of H2O. And according to my mole ratio, what numbers do I put in there? 1 and 1. So my moles of H2 cancel. And without a calculator, what's 20 times 1 divided by 1? 20. So again, like I said, you could reason that one out in your head pretty well. I wanted you to write it out because as we progress, our numbers aren't going to become so nice and easy. Okay? But the concept is the same. The process is the same. Okay? All right. So, what's the oxygen to water ratio? So go back to that same equation. What's the ratio of oxygen to water now?
1 to 2.
What's the 1 to 2, exactly. The coefficient of 1 in front of the oxygen and a coefficient 2 in front of the water. Okay? So now if I have 20 moles of oxygen, how many moles of water? So let's set that up. 20 moles of O2. What's going to go on the bottom?
Moles of
Moles of O2. What's going to go on the top?
Moles of H2O.
Moles of H2O, because that's what I'm looking for. Said how many moles of water. What's my ratio? What number is going to go in front of the O2, moles of O2?
Be 1 to 2.
1 to 2. For every 1 mole, according to my equation up here, for every 1 mole of oxygen, I have 2 moles of water. So, how many moles of water can I make? 40. Okay, so with the mole ratio, I'm learning how to take moles of one thing and turn it into moles of a different thing. Okay, which is going to become super important later on. Okay. Any questions? What would I do if I wanted to find out how many atoms, I'm sorry, not atoms. What would I do if I wanted to find out how many molecules of water I would have in that 40 moles? So in this 40 moles of water that I have right here, how would I figure out how many molecules of water that would be? 1 mole of something is always equal to 6.022 times 10 to the 23rd of those things. I don't care if they're atoms. I don't care if they're molecules. I don't care what they are. So if they're asking how many of them, you're going to use Avogadro's number. Okay? If they say how many moles, well, then we use molecular mass and all this kind of stuff. So I would take the 40 moles and I would multiply it by what? 6.022 times 10 to the 23rd. Okay? So molecules, atoms, do the same thing. Don't let those words think, oh, there's something different. There's not. It's the same thing. Okay.
Let's do this whole page.
No, I don't want to take some to the whole page. We may come back and finish up some of it later. The hydrate worksheet we are not going to do. The main thing about the hydrates that you are actually don't really. The main thing about hydrates you need to know is how to find the molecular mass, and that's just finding the mass of the waters that'll already be in the formula. Empirical formulas, you need to remember about empirical formulas. Let's do this. How do I want to do this? Let's see if I can find a practice problem on empirical formulas. These are naming. Here we go. Let's look at this practice problem. All of the following are empirical formulas of steps. So you need to understand the definition of an empirical formula. Empirical formula is the smallest whole number ratio of atoms. Okay, so for example, on our empirical formula POGL, we had this compound, C4H8, as the actual molecular formula. What would be the empirical formula for that? What's the smallest whole number ratio for that? 1 to 2, exactly. So it would be CH2. Okay, so you're going to do the same thing here. So which of these choices is the smallest whole number ratio? Would it be 6 over 6? No, that's not the smallest whole number ratio. 2 to 3 to 2? Maybe. CHO2? Maybe. CH2, yes. So A, C, and D are all empirical formulas. What is my question asking for? Except. See, I read that backwards. That's why I marked out the exception. So be careful when you're testing to look at, I want the one that's except. So B is the correct answer because it is not a small whole number ratio. It is not an empirical formula. Okay? Why is it not an empirical formula? B?
Because it's not.
Because I can reduce 6 to 6 down to 1 to 1.
And you can't reduce.
And I can't reduce any of those others. Yeah. Okay, so let's find another empirical formula type problem. Blah, 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 blah. Blah, blah, blah. Molar mass, molar mass, molar mass, molar mass. Okay. Let's take a look at this one. What is the empirical formula of a compound with the following composition? Okay, so this is important to know. With empirical formulas, what we do is we take their percent compositions. We assume that we have 100 grams. And if we assume we have 100 grams, we can take all of those percents and make them grams just by putting a G. So instead of saying it's 10.4%, I can say it's 10.4 grams of carbon. Because what is 10.4% of 100? 10.4. Okay, so that makes it really easy. So I have 10.4 grams of carbon. I have 27.8 grams of sulfur. And I have 67.1 grams of chlorine. So that's my first step. The second step is I have to turn every single one of those grams into moles. So
You have to do that on all of them?
on all three, yes. So how many grams are in 1 mole of chlorine? Periodic table. So let's just say 35. All right, so 67, is it 30, what is it, 35.45 or is it 30?
35.45.
Let's do 35.5. Let's not round it that much. So 67.1 divided by 35.5 is how much?
Take a lot of time.
67.1 divided by 35.5.
1.89.
1.89. Okay, and over here, we're going to do the same thing, right? So 27.8 divided by 32. What is that?
0.86.
Okay. Yeah, okay, you're right.
Why don't you look?
Because my mind was working slow. It was me, not you. All right, so 10.4 divided by 12 is how much?
0.86.
0.86. Okay. All right, so now what I do is I take the smallest number of moles and I divide it into all three. Okay? So 0.86 divided by 0.86 is just what? 1. So I have 1 carbon. I have 1 sulfur. 1.89 divided by 0.86 is how much?
2.197.
2 chlorines. I round it to the nearest whole number. So 1.86 divided by 0.86 is 2 point something or another, but it's not enough to round up, so I just drop it off at 2. It means I have 2 chlorines. So this formula would be CsCl2.
Why did you put 0.86? Why did you divide that by 1.8?
Because I need to make those whole numbers, and the only way to make it a whole number and to get the proper ratio, because that's what an empirical formula is I divide the smallest thing into everything else.
And they're the same.
And they happen to be the same. So. Okay? That is my empirical formula. That tells me the smallest whole number ratio of atoms in there, not the exact number of atoms. Okay? So the main thing to remember is change your percent to grams, because we're going to assume we have 100 grams. And then change the grams to moles, and then divide the smallest number of moles into everything else that you happen to have. Okay. Okay, let's look at 20, because 20 is different. 20 says with the empirical formula of a compound is NO2, its molecular mass is 92 grams. What is its molecular formula? All right, well, to do that, I need to compare the mass of the empirical formula to the mass of the molecular formula. Because remember, they're related by their ratio. Remember, the empirical formula is the smallest whole number ratio, but the molecular formula is the actual ratio. Okay? So what would be the mass of nitrogen and 2 oxygens? So nitrogen is 14, 2 oxygens is 32, the 46, right? Okay, so if I compared 92 to 46, what do I get? 92 divided by 46 is what? 2. Yeah. So that means that my molecular formula is 2 times the empirical formula. So it would be N2O4. They're the same atoms. They're just, empirical formula is the smallest whole number ratio. Molecular formula is the actual number. So even their masses are then ratios of each other. Okay? That one you might want to jot that one down, because you don't know that you had a POGL that had one like that. I know I believe our lab may have had one similar to it, but I don't know that our POGL did. Oh, I know, our free response question did. Our free response question had a question like this. So, the one you had to practice on? Okay. All right, so if we have this compound, MgSO4 and 7 waters, what I want y'all to do is find the molecular mass of that. So get you out a piece of paper, or you can do it on your calculator, on your computer, whatever. Find the molecular mass of that thing. Molar mass and molecular mass are exactly the same thing. Don't let that confuse you. So when it says find the molar mass, that's what they mean. Find the molecular mass, molecular weight, all that's the same thing. What am I going to do? While y'all are doing it, I'm going to do it too. MgSO4 and 7 waters.
The wall, but now we're finding the molar mass.
Mm-hmm.
Is that a multiplication symbol like right at the 7?
Yes, it means it means there's 7 waters. It's not a literal math multiplication symbol. It means there's 7 waters that get added into that compound. So you'll find the mass of MgSO4, then you'll find the mass of 7 waters, and then you'll add them together. Or you could just do it all at once. But anybody got an answer yet? What do you think it is?
111.
I don't think so. Let me try it again. It's possible I messed up. It's very possible.
I got 246.483.
Yes. 246. Yes, that sounds right. So you'd have 24.3 for the magnesium, 32 for the sulfur, and then you actually have 11 oxygens, 4 in the first part, in the SO4, and then 7 more back here. So you would say plus 11 times 16, and then you have 14 waters, or 14 hydrogens. Plus 14 times 1.008. Yeah, 246.4. Okay, so if you didn't get 246.4, we need to figure out right now what you left off or what you did wrong or what you were, where your miscalculation was. Because unfortunately, with a problem like this, you're going to use that 246.4 in everything else. And this is where showing your work is going to help, because if you get A wrong, but you show your work and everything else is correct, I'm not going to count off everything. Okay, if you've shown me that you know how to do percent by mass, you just messed up on A, I'm not going to count the whole thing wrong on B or C or D, unless you don't show me work, and then I'm going to count the whole thing wrong, which would not be fun. So show you what. Okay? So any questions on A? I don't want to move on to the rest if we don't know how to do A, because that would be pointless. You got A? Okay. So A we found to be 246.41. All right, so calculate the percent mass of the anhydrous salt. So this word anhydrous, what do you think that means?
They not hydrated.
Not hydrated, yes. So it would mean
Just like the
not what? It means it has no what in it?
water.
Water. So anhydrous salt would be just that part, without the water. Okay, so anhydrous means without the water. So the magnesium plus the sulfur plus the 4 oxygens. What is that? What is that?
120.37.
Yeah, 120.3. Okay, so let's just see if we can figure out how to do C. C will not be on your test because we haven't talked a whole lot about hydrates, but I want to see if you can figure it out just mathematically. Can you figure it out? It's saying calculate the percent of water in this salt. What would you do? What do you think?
Divide the top number by the bottom number. Divide A by B.
Okay, why would you do that?
Well, because the first one is with the water.
Mm-hmm.
The second one is without the water.
Mm-hmm. Yeah, that's what you would do. You would divide the two. So 120 divided by 246.41 times 100. Okay, let me double check and make sure that that is what I want it to be.
Shouldn't it be a little more than 57?
Yeah.
I don't know if I-
Um,
I don't know if I-
that's what you would do. You would divide. Oh. You're almost there, but not quite. So you're not going to divide them directly. And we may be off on our masses. So 24.3 times, what is sulfur again? 32? 32 plus no, it's 25. Okay. So what they did, yeah, 146.4. Oh, I misread the question. It didn't say calculate the mass of the anhydrous salt. It said calculate the percent by mass of the anhydrous salt, which is what we would have been figuring out. So they got 135.32 for the magnesium sulfate, divided it by the 246 times 100. That gives us 54.92% magnesium sulfate. And then you subtract from 100 to get the amount of water. Not sure why we're so off on our grams per mole for magnesium. (24.3) plus 32.06 plus 63.96. I think this has a mistake in it. Because if you add their numbers, that does not give you 135 for those 4 things. So I think they made a mistake in that number right there. So it should be 120 divided by 246.3 0.39 times 100. 48.8% is the percent of magnesium sulfate, and then you subtract that from 100, and you get 51.2% water. So yeah, I think that's an incorrect number. But as far as this goes, you would not need to do, you would just need to know how to do A. And B. Okay. So, questions on calculating moles, mole ratios, percent compositions, empirical formulas. Yes.
The naming one?
Mhm.
Where is it on school?
Do what?
The Quizlets for naming compounds.
We're gonna go over those next.
Okay.
Yeah. Okay, so if you, let's go into Unit 4. And I believe the first quiz we had was on the 8th. Yeah. So let's look at this one first. I had it right the first time. So in second period, what I did is I went over this part first and then did the problems last. So if we don't get done with this, you can go watch the first part of the second period video. I'll have them both on there. But one of the first things you have to ask yourself when naming compounds, because it's just memorization. There's a set of rules for ionic compounds, there's a set of rules for covalent compounds, and there's a set of rules for acids. You have to be able to recognize if something is ionic, covalent, or an acid. Okay, so the first thing you're going to ask yourself is, do I have a metal? Okay, the way you're going to know that is you're going to know it by the periodic table. So let's look at a periodic table. So basically, on a periodic table, everything, this little line right here is like our dividing line. These are our metalloids. It means they act like metals and nonmetals. But pretty much everything from aluminum that way is a metal. Okay? Everything from here this way is a nonmetal. Okay? Everything in the center right here are transition metals. All right? So you need to be able to look at a periodic table and know where is what thing. Because otherwise you're going to memorize everything. Why do that, you know? When all you need to memorize is 4 things. Why memorize 160 or whatever? So in that first problem, is barium a metal? Yes, it is. Because what group is it in? It's in the second group. It's on the left side of the periodic table. It is a metal. So because it's in group 2, what charge does it have? That's the next question you got to ask. Do I have a metal? Yeah. Charge is +2. That's the second thing. Is it a transition metal? No. If it's not a transition metal, you do not have Roman numerals. You can cancel those out.
Yeah, 50-50 chance.
Okay? Then you have to know your polyatomic ions. Now, your polyatomic ions, unfortunately, you just have to memorize. If there is more than 2 elements in something, you got a polyatomic ion. Is there more than 2 elements in this formula? Yes, there is. We have a polyatomic ion. SO3 is the polyatomic ion sulfite, not sulfate. That's SO4. SO3 is sulfite.
Whenever you're ready.
So, which one would it be?
Very-
It'll be the first one. All right, let's go eat lunch.
Let's go.
Make them suffer through the same hour and a half you had to suffer through.
Oh, I will. I will.